Welcome to another exciting episode of the Geek Nader podcast. I'm your host, Deval Yapte, and today we have a very special guest with us. Someone who has made significant contributions to the world of data systems. Gwen Shapira. Gwen is a well-known figure in the database field. She's the founder of NileDB, a groundbreaking database re-engineered for multi-tenant applications. Gwen has an impressive background, having authored Kafka, the Definitive Guide, and spent years working at Confluent, where she contributed extensively to the development of Apache Kafka and cloud-native data architectures. In this episode, Gwen shares her valuable insights on how NileDB addresses common challenges faced by multi-tenant SaaS applications and provides a robust solution for scalable, secure, and efficient data management. We also discuss Postgres, its advantages, and why it was chosen as the underlying database for NileDB. So sit back, relax, and join us as we explore the amazing database that is NileDB.
Gwen, I'm absolutely excited to have you here, and I'm really thrilled. I may not look like as thrilled as I am because it's too late for me. I'm in Berlin, but I'm absolutely thrilled. So welcome on the show. Finally, I'm really happy that we are able to do this. And let's start with a little bit of introduction about yourself, about your background, and how did you end up creating NileDB.
Yeah, so first of all, thank you for the nice words in the intro. And I'm also a huge fan of your show, and I'm excited to be here. I don't know if I look excited, but I definitely am. And yeah, as you said, I've been at Confluent working on Apache Kafka for a very long time. And before that, I was also doing databases. Before Confluent, I was at Cloudera working on Hadoop, working with big data in Pala. And then before that, I was working on Oracle and a bit of MySQL. So I basically spent my entire career working with data, and a lot of it was in professional services, like just helping developers use various data systems. And some of it was in various roles. At Confluent, I did a lot of roles. I was product, I did marketing, all kinds of things. I led an engineering team. So my last role there was really the cloud native engineering for Kafka. Like, just if you've read the core paper, then that is my former team who wrote and published that. So I'm very proud of how they got credit for the work. And when we founded Nile, it was founded by 3 people from Confluent. So in addition to me, my co-founders were actually from the Confluent Cloud teams, which were much larger teams than the Kafka team. It was just creating everything around authentication and account management, billing, deploying services, UI. This was a lot of people and took a lot of time. My co-founder likes saying that when he started leading the team, he was a team lead. He had an 8-person team, and he thought that in half a year he's done and can go do something else. It took, I think, 4 or 5 more years. It still isn't done. The team grew to something like, I don't know, 200, 300 developers. As the team grew, he became VP of engineering. So it's obvious that building B2B applications, building control planes, building software as a service was a much larger problem than me, just from entire career of writing databases, had any idea how hard it can be to just build those complex applications. And when we founded Nile, our mission was we want to make it really easy to build software as a service. That was our strong desire with this company. And it went through some iterations. We had different ideas. But at some point, out of conversations, and we talked to hundreds of startups and founders, some of them are doing indie SaaS, some of them are more well-established, more well-funded. And we discovered that one of the common problems was really around the multi-tenant databases. There were 2 common architectures for that. I can explain what they are if you'd like, but they all involve trade-offs, and it's nearly impossible to pick the right architecture when you're just starting, which means that maybe a year or 2 down the road, you're facing really painful migrations. And it was a repeating theme in tons of conversations. So when we were thinking about a place where we can have a lot of impact, we're like, what if we had a database that was really built for those multi-tenant B2B applications? And it would handle things like secure authentication, because right now there is this big gap where people authenticate to an application and then their identity is fake toward the database. What if it gives you real isolation between customers, but without all the trade-offs involved in managing thousands of databases for your customers? This was something that once we understood the pain point, we were understood that we had the experience to solve it. Because I ran Cloud Native Kafka at Confluent, and Cloud Native Kafka was multi-tenant, and Confluent Cloud was exactly this kind of B2B applications that needed to handle all those concerns. Like, actually, we understand the problem really well, and we think we have a solution that wasn't there before. But whenever we shared it with anyone, they were like, "Oh, why didn't it exist before? How come databases existed for 40 years and nobody did it?" So yeah, I'm happy to talk more about exactly more details.
Absolutely. When you were explaining this, and I also read a bit about NileDB, and I was also following the journey of until GA. And I was always asking this question, like, this problem seems so basic, like it's so common, but why isn't it solved yet? Like, better way. Um, I've worked with so many companies and they have their own ways to provide this kind of isolation between tenants, and none of them works perfectly. Either it's too costly or either it's too painful operationally. And I totally feel the pain whenever I work with database teams or product teams, even there's one problem or the other. And it feels like this is the same problem that we are trying to solve again and again, but not in the best possible way. Right.
That's
So I'm
exactly it.
absolutely exactly. Yeah. And I'm really excited to learn how this thing works. But before that, I have a couple of questions, and I've asked this, I don't know, hundreds of times, and I probably know the answer as well, but I guess everyone has a different flavor of the answer. Why Postgres?
That's a great question. Partially because Postgres is actually the database I've used less. I had more experience with other databases. So first of all, it was open source, which helps a lot. And the second thing was that when we talked to other SaaS customers, it seemed like it's more popular than MySQL, which was important to us, and it was gaining in popularity, which was also important to us. And we really liked how it combines a lot of features that you don't normally see together in a relational database. So obviously it's a relational database, and it's not just a relational database. It also has a lot of, for an open source database, it has a lot of enterprise features. It scales relatively well. It has partitioning. So we were really impressed with how mature it is as a relational database. And then it also supported non-relational data. So you can store JSON, and it has a bunch of optimizations and JSON indexes. And this was so exciting to us because we discovered a lot of startups pick it because it doesn't force them to choose between relational and non-relational database. Do they do MySQL or Mongo? Can be a hard question. But if you use
Yeah.
Postgres, you actually get both. And now with AI, it also supports vector embedding. So you don't need a separate embedding store. It supports data warehouse type workloads. You can do pretty advanced reporting on it, so you don't have to have another data warehouse. Again, eventually you may have a separate data warehouse, but when you just get started, having just one DB for everything is so powerful. And so we were very excited about it. We are building something for startups, and this is obviously the perfect database for a startup. And then it's also super extensible. Like, we wanted to build something nobody else did. We needed a way to extend the database. So obviously the extension interface is fantastic, and it gives you tons of power, from very simple extensions that just do some small functions and maybe a background thread, to something that, like, we build, that really uses all the hooks inside the different Postgres capabilities, that you can really say, oh, whenever someone runs a DDL, call me first so I can do some stuff like distribute the DDL to all the tenants before anything else happens. So it gave us a lot of the power we needed very easily. And it is really nice code. Like, just the community is friendly. It is known for being slow in the sense that if you want to contribute a new feature to the Postgres community, it can take a while. Getting reviews is tough. People are really picky. But as a result, the code base, it's amazing. I don't know if you've ever opened your database and read it, but it's very readable. And you can read how does query optimization work? How does row level security work? How does do transactions work? And the README is good, the code is readable. It's very empowering to be able to dig the internals of your own database.
Absolutely. I totally agree with that. And I also love Postgres. I recently looked at the code when I was trying to understand the recent optimizations of the in clause, how they have done it. I was really impressed with the documentation around like all the optimization. It's
Yes.
amazing. Like a person like me, I can totally understand what exactly is happening there. And yeah, I totally agree with that. And yeah, the ecosystem itself is so vast these days. As you mentioned, there's like vector embeddings available. There's also search, there's analytics. Like I was talking to
Yeah.
ParadeDB and they are doing some amazing stuff with Postgres as well. Totally fair enough, fair choice. um, let's dive right into NileDB. And there are some key features that I really want to focus on. The one is, of course, tenant isolation and how exactly it is done. The other one is I've seen a term used on the blog. It says AI native. So I really want to understand that term and how NileDB supports that. So let's start with the tenant isolation. Let's say I'm a SaaS company and I support hundreds and thousands of customers, and I want to use a database like NileDB. Where exactly tenant isolation comes into picture, and how should I go ahead and think about it as a problem? What kind of problems do companies typically face? So I guess one problem you mentioned about the security, where it is faked security on the database layer, even if you have the security at the API level. What are other problems that people face?
Yeah. So for one example is that this is not like day zero problem, but usually by year two of a company, especially if you're a SaaS that starts in Europe or in India, you need to support multiple regions. You need to have some of your tenants in the US, some in Europe, some in Asia. Otherwise, performance is frankly going to suck and people will complain about it. And this is something that actually came up in the very first conversation we've had with founders of, I think it was Rocket Lane. It's a company in India that does customer onboarding and customer support systems. And when we talked to them, they were like a 2-year-old company. Now they're actually quite big and impressive. And they're like, we started with just one data center, but now we have customers in the we didn't think we'll have customers in the US so soon. But today, when marketing is so global, when usually you do a podcast and suddenly people all over the world hear about you,
Yeah.
then you need to be in different places much sooner than you expect. And then if you follow the traditional model, suddenly you need to spin up a bunch of machines. This is obvious. But you also need to figure out how will customers actually like you'll have applications in all those places. You need each application to talk to the correct database. You need to somehow route customers to the correct applications. There is a bunch of ways to do that, or route them to the right database, even if they connected to an application in the wrong zone. So suddenly there is months of development work coming up just as you're starting to grow. While we believe that the right way to have a tenant in a different region is to do insert into tenants, tenant name, region name. And maybe if you want to have specific amount of resources for a tenant, you can also specify how many CPUs you need for them. But it shouldn't be spin up an entirely new region with all those machines, a new Kubernetes cluster, figure out how to do routing. Obviously, Nile is a managed service. We deploy it for you. But it's also a lot of our infrastructure is really around how do we make sure that when you query or insert on behalf of a tenant in your application, how do we make sure it actually ends up in the right database, no matter where the database is in the world, and no matter if it's on shared compute or you decide to give a tenant a database completely of their own.
Okay. Okay. Yeah. That does make sense, and I understand the problem. I've also seen some companies that I've worked for facing this exact problem, and it becomes a roadblock. Like suddenly the company is growing. Oh, 2 years old, we are really doing amazing, and then suddenly it's all falls apart because we don't know how to handle this problem,
Yeah.
and we don't have the expertise, right? Like setting up a new region and networking around it and making sure it is performant, it's really a huge challenge.
The headaches that nobody needs. Another interesting thing is we've seen incidents that happen because one customer asked for a rollback, or you did a maintenance, it failed for one customer for some reason. Now you need to do a rollback for that customer essentially, and nobody knows how to restore a backup for just one customer. Yeah. And nobody wants to actually restore data for all customers because only one customer wants their old data back. Everyone else wants the new data. So this is another thing that I've actually, for the first time I've seen it, I was consulting for Ning. If you're old enough to remember, they were one of the early social networks. Yeah. And Ning was very multi-tenant. There's faced a lot of multi-tenancy challenges because of just the rate they were growing was insane, and they were giving free accounts. So everything was just falling apart. And then we needed to restore a single tenant. And there is nothing automated. You have to restore everything on a separate database, which takes hours and hours, even if you have good SSDs, because it's just a giant database. And then you have to pull out the rows from the right tenant, insert them to the right place. You have to figure out what to do with conflicts because the tenant may have changed some stuff. So it's a complete nightmare. Like it's hours and hours of downtime for the tenant. If it happened to a lot of tenants, you can do it for weeks. And apparently there was the companies that does Jira and Wiki had 2-week downtime for a similar reason a few years back. So yeah, this is another big one.
Very interesting. And still, it's not yet solved completely. Great. Let's talk about how that exactly works, right? Like I've seen in one of the companies to have that kind of isolation, they used to spin up a new database because they anticipated that, okay, we have multiple tenants, but they're not going to be like hundreds and thousands. So let's do it, right? Like whenever they onboarded a new customer, they just create a new database. It's completely isolated. But it cannot work for if you scale up to 10,000 customers, right? It is going to be an operational nightmare and also costly.
Yeah, exactly.
And the more common solution that I've seen is
dump everyone just one database into a database and have a tenant ID column. Yeah,
exactly. So how does NileDB solve that problem? So when let's say I onboard a new tenant, how is it working? Like right from the API layer to like, I don't know, storage layer, for example. Let's walk through that process.
So first of all, we may want to talk through two flows because we actually you can choose either. So if you know in advance that a tenant is going to need dedicated compute, you can tell us that, hey, we want this dedicated. But the main path that, as you said, everyone starts in the beginning is that they actually start on shared compute for all the tenants. First thing you do is Nile, click create database. We're serverless. This spins up your database. It comes with some tables we know you're going to need. So there is a tenants table built in, there is a user table, there is a user tenants which connects them, and there is a bunch of tables for things like credentials or IDC providers, things along those lines. First thing you probably want to do, and this can be just to play around or more likely through an application, is that you want to create maybe a user so you can sign up. This can be through Google SSO, this can be email password. So you have a user. The tenant gets created with the user. It's a tenant that it doesn't there's no random tenant. This thing starts with the user. The user creates a tenant. This goes into the tenant table. So now you have a tenant in the tenant table. Behind the scenes, what we do quite a bit there. We look at the tenant you created and see, okay, it has to be in this region, it has to be on this compute. We pick, if you're shared compute, we have an entire cluster, we pick something with enough resources, and we say, okay, this tenant is going to be over there. If the resource we found for you doesn't have your schema yet, before we did all that, you probably created some tables for your application. I don't know, we'll use to-do list as an example. You did create table to do. We created it in our shared cluster for you. But if we decide to place the tenant on a new machine that doesn't have your schema, we will make sure it has your schema. And then we have a tenant. Next thing, probably the tenant want to create some to-dos, so it needs some data. So when you do insert into, you are going to do it as normal. You're basically going to say tenant ID, insert into tenant ID, name of to-do, title, status, description, whatever. You insert the row. We have a proxy, a router. We inspect the insert is for this tenant. You may have even set the tenant ID globally. Although if you just created a tenant, we will actually assume that the next insert is going to be for that tenant, and we'll also already set the context for you as long as it's in the same transaction. So the entire transaction will already get routed to where the tenant is. And then every insert you do, every select, everything is already happening for that tenant. Now, let's say another user logs in for that tenant. Now, again, you start a transaction, you do insert, you do a select. There's two options. One of them is that if you do an insert and you have a tenant ID, we know what tenant it is, we route it to the right place. If the select has where tenant ID equals, then we route it to the right place, not a problem. However, if you can also say, set Nile.tenant ID equals and the tenant ID, and then the entire transaction is already routed to the right tenant. And you don't have to specify the tenant ID again, essentially. It's like you're in an isolated database for that tenant. That's the user experience. Now, when you do an insert behind the scenes, we don't just insert to a table, although it looks like we're inserting to a shared table. In practice, we have our own storage manager. So we actually write it to isolated data files. The blocks are isolated in memory. And this is what allows us, if we need to move the tenant somewhere else, we know what files to move. If we need to take a backup and restore, we know exactly where to find your tenant. We have it all isolated for you.
Okay. Interesting.
So basically the important bits to remember are the proxy that routes each tenant to the correct tenant database, the transaction coordinator. So when you do things that have to, like DDL, essentially, you do create table, we need it to happen on every machine that has tenants for your database. Then we have assistants to do distributed transactions for that. DDL in Postgres is transactional, so we maintain the same guarantees. And then we have the storage layer, which gives you the isolation of tenants on shared compute, still enjoy the isolated storage, which obviously have impact on performance, and everything is faster because data is actually separated. You don't have to scan everything if you just need something for a specific tenant.
Okay. I have this high level understanding based on your explanation. And I also understand the separation that is being provided. And there's already this context when there is a transaction, there's this tenant ID context always, right?
Yes.
And as I can imagine, there can only be one tenant within a transaction. And I cannot do like a transaction with multiple tenants in it, right? So inherently it is not possible, which adds to the security point, right? Like I cannot mess
so
something up.
this is correct. If you're in a one tenant and you're trying to do an insert that actually has another tenant in it, we will absolutely block it. The one exception to transaction cannot have multiple tenants is that if you have a transaction that only does selects, let's say you're doing a big report about all your customers because your manager asks you to check how many users does each one of my customers have, then we allow you to do a select across all tenants. You can basically do as a developer, not as a user. You have to identify as a developer and say, I am a select star from users join tenants kind of thing. And you can get this entire report, but you cannot do inserts and updates or like any kind of changes without specifying exactly which tenant is doing it. And we make sure that you're acting on that. We also validate, like you're also saying, I'm doing it on behalf of this user. You provide us with not just the tenant ID, but the user ID. So if you're trying to do something and the user doesn't have access to the tenant, because I don't know, a lot of people put the tenant ID in the URL, which can be easily hacked. So if someone tries to hack the URL and act on a different tenant, then we obviously block that and say, hey, your user does not have access to that tenant.
Okay, interesting. That does make sense. Just to understand a little more. So you said as soon as let's say I do an insert into tenants, right? And it inserts a tenant, where this tenants table exists, because at the end, when I have for data for each tenant, it's isolated. Where is this common table that stores all the tenant exists?
Oh, wow. So this is a brilliant question because nobody asked me ever. And we had so many internal debates around it. And like, The development team was just very split on the right way to do it. So I'll tell you what we ended up with. And obviously, like everything, it has pros and cons. So the way we do it is that, first of all, the tenant table is considered what we call a tenant-aware table. So it's split between all the tenants, like every virtual tenant database, as we call it, has like a slice of the tenants table that has just this tenant. A developer, because it can query across all the databases, can do select star for tenants and actually see everyone. So this is a sharded and split table. I'll talk about that in a second, but behind the scenes, we also have a kind of a shadow tenants table. This is specific to each region that none of our customers have access to. This is something that we maintain, but we use it to guarantee things like unique tenant IDs, things like routing, right? We need one place to look to understand where each tenant lives. All the placement information is there. The answer is both, but the place where all the tenants are actually in one single table is hidden and mostly used for enforcing certain things.
Interesting.
Yeah, the other thing that I wanted to mention, unless I don't give the wrong impression, we also have a concept of shared tables. Those don't have tenant ID. If you put data in a shared table, every tenant will have access to it. One of our customers does something around organizations that handle ecological concerns in, I think, Australia. He had a big list of, information about animals in different locations. And this big list was shared between all the tenants. Everyone had access to this. And again, you cannot modify this list if you're in a transaction in a tenant, but you can query from this shared resource.
Very interesting. Okay. So there's also a possibility to share data across tenants.
Yes, exactly.
But then you don't get the tenant or the isolation part for
Exactly.
this share table. Okay,
Yeah.
that makes sense. When you started explaining this tenant isolation concept, you used a term, or you mentioned something like, if you already know that a tenant will require a separate compute, right? Then you can decide to split them. How do I know as a developer that a tenant might require a separate compute? And you specifically talked about compute and not exactly storage. What is the difference?
Isolated. So we have no need to ask you if you need separate storage. You're going to get it whether you want it or not. We believe is core value for product, that we don't mix data for different customers. But we do have shared compute because, as you mentioned earlier, it's just a lot cheaper not to provision machines and not to have all this overhead of running Postgres for every single one of your customers. However, it really depends on your sales model. So I talked to a guy whose entire business is selling to news organizations. Now, most news organizations are quite large and have resources. If you're selling to Fox News, you know that they're probably going to afford and be okay with their own compute, that they are probably going to justify it. Again, if you sell to New York Times, same story. They're going to have a lot of data. They're going to enjoy their own resources. They're going to be very active, and you can charge them accordingly. So if your entire business is, it's an entire business model. I'm selling to large organizations. So I have a sales team that knows how to wine and dine them. I'm used to those white glove onboarding. Maybe they sign up from a click on the website, but then they're happy to, when they look at the pricing page, to actually click on the call us button that no developer ever clicks, but big organizations actually prefer to do that. And so when you have this white glove model, you actually talk to them in advance before the first tenant is ever created. And you have this nice conversation, and you know that you even know exactly what compute size you're billing them for, essentially. So this is that model. Obviously, if you're self-serve, you don't really have a way of knowing unless you basically ask them what plans they want to be on very early on, and you have dedicated extra expensive plan, and then you just put it on expensive compute. So this is what we're imagining, something that we really want to allow, and we think we're on the right technical path for that, is obviously everyone is on shared compute, everyone's happy, and then you realize that one of those customers is about to become the next Fox News. They're getting big. And then when they're getting big, we really want you to give the ability to not just enjoy our auto scaling, but say, okay, this is a big one, let's move them to their own. I was talking to a guy in Discord. Discord has, I don't know, millions and millions of tenants, you can imagine. And I think it's famous. They use NileDB, they use the auto partitioning, auto scaling. Like, they're pretty happy with that. And they managed to make it work, which I admire. But it's very obvious that some Discords are so much bigger than others. There is the Discord for, I think, Midjourney or something like that. It's like insanely large, insanely active. So I'm happy that they made it work while putting them on the same shared compute that everyone else is in. But if I discovered that Midjourney is my customer, I would probably click the move to dedicated compute button and make it work that way.
Yeah, I think that makes sense. And as you mentioned, it also depends a lot on your business model, right? And depending on what kind of customers you're onboarding, you can get a good idea. First, if they're paying you a lot of money and they have such a use case, you can of course have like a separate compute for them. If I have to look at, let's say, like a high level architecture diagram, so when I look at Postgres, it's fairly simple. It's just storage, this compute processes and a file storage, and simple. When I look at NileDB, what are the high level or the larger components am I looking at?
Yeah, I would say, first of all, Postgres itself is a large component, and we kept all of the components inside the Postgres. We have our own storage manager. This is half inside Postgres and then an additional external storage service. And we have write-ahead log shipping that goes between them. I think I already mentioned we have a transaction coordinator for spreading DDLs across different machines. We don't do the same thing for normal inserts and deletes because those are always specific to a tenant. There is the proxy that routes all the requests to the correct tenant. And we also have REST API services. So for things like user sign up with stuff like Google and GitHub, all those need to go through actual Google OIDC flow. We have a service for handling API requests around that. I think those are the big ones.
Interesting.
I'm like, my developers are going to kill me if I forgot anyone's pet service. We also have a data plane, control plane separation. So what I described now is the data plane, but the control plane is basically its own service and it has its own database.
Just to make sure our audience understands these two terms, right? Like control plane and data plane. What exactly does it mean for a database like Nile?
Oh yeah, important. So when you sign up to Nile, you're a developer, you sign up and you click create database. And after a database is created, you click generate credentials from a database. So you actually get this nice connection string with username and password. Until now, everything is in control plane. This is where developers authenticate. This is where we manage our list of databases and the access to it. Now, if you look at the URL in the database connection string, you're actually going to see that it says something like Nile USW2, something along those lines. This URL already points you to data plane, and we have URLs for specific regions. We also have more global URLs. We also have tenant-based URLs. We have all sorts, but the idea is that the moment you connect to a database, now you are in a region. So the control plane is where you manage a collection of databases. Yeah. Once you connect to the database itself, whether it's you as a developer because you want to create some tables and run some reports, or it's via your application doing operations on behalf of users, this is all data plane.
And let's talk a bit more about the storage manager here. And you mentioned storage manager is intersecting between the Postgres layer, and then there's this storage service that you have as a separate for providing this isolation for storage. But is the format or the storage format same as we typically have in Postgres, or you had done some changes there as well?
We have done changes, and this is something that we honestly still iterate on. But we do need additional information for every record. We need to know which tenant it belongs to. So some modifications were necessary. This is something that I honestly, I haven't really went into that deep into the internals. So I don't know if there are any additional modifications. I'm trying to think like if there was anything we did to make it more efficient or anything along those lines. And I don't think we did, but we do have compaction process where we turn write-ahead logs into data blocks and merge them with existing data. So there may be additional information to enable this that I'm not familiar with.
Okay.
That's it. You can now you know that I'm not a real developer.
Yeah, there's only as much deep as you can go in any area, right? Like you have to uh, stay at a high level as well. I totally understand that. I'm trying to understand. So on storage layer, I understand that there is a storage service and you have like complete isolation because you're storing data separately based on tenant ID. On the compute level though, is there a protection where, let's say I don't have a separate compute because I didn't plan for that, but still, is there any protection where, you know, to protect our, workloads, let's say one tenant is doing a lot of computation or some bad queries running and that is taking down some other tenants as well? Or do you give some indication that, oh, this is the right time to move this tenant to a separate compute?
So there's a few things. First of all, we never force anyone to move to a separate compute. It's always
Yeah.
your choice. We bill for your use of CPU. Like we're serverless in the sense that we sell you CPU seconds and a chunk of the memory to go with that. So it's our best interest to never throttle you, essentially, to give you
Okay.
as much compute as you're going to need. So if you have a tenant that is using a lot, we're actually not going to try to throttle or block it. We are going to try to move it to a different machine with more resources on our cluster. So this is very similar if you know how DynamoDB works or
Yeah.
how S3 works. We basically constantly try to rebalance things in the background. This is a technique that we also used in Confluent Cloud. There was auto data balancers that constantly checks which tenants are causing the most load and try to move them around. In order to make this feasible, we actually needed to do zero downtime, literally zero downtime data migrations, which is, as you can imagine, work in progress because it's extremely difficult. We have to move. What if the tenant is in the middle of the transaction, for example? You need to move some transaction state. Even if they finish the transaction, there may be other ongoing selects that need to be able to see the old data versus new selects that need to be able to see new data. This is all Postgres MVCC. So we had to move a lot of transaction state with the tenant, so the actual rows will continue making sense on the new machine. But yeah, this is our main mechanism for that. And I think I'm trying to think if there's anything else we do with the shared compute for isolation. But yeah, basically making sure that the blocks in memory are separate helps us, and tracking the transactional state so we can migrate the correct state is a big deal.
Okay. That seems really powerful. So are you saying that, let's say I have some transactions in place that are running and suddenly you want to scale up and then you move that state, the transaction state, to, let's say, a new machine to upgrade the compute size so that can actually run efficiently? And if I understand correctly, did MVCC help you there because you always have a separate version for a given transaction, or some other techniques are used?
Yeah. So first of all, MVCC is extremely helpful.
Yeah.
And it meant that we didn't have to implement a lot of things from scratch, but it did mean that we had to work with MVCC, meaning that there are all the sequence IDs that exist in one machine and now suddenly someone is going to be looking for them on a different machine. So it was really a matter of really deeply understanding how MVCC is implemented. I mentioned earlier that the Postgres code is very readable and that it's so good that the transaction parts are so well documented. We're very grateful for everyone who worked on it, that they made it fairly easy to understand how MVCC works under the hood so we can play along.
Okay, interesting. And it's also very interesting that you don't throttle a customer because You want them to give as much compute as they want, because it's also fair because they are paying for that. And not making that decision on customers' behalf is actually very useful, because you actually don't know if it's a valid use case or it's just a bad query, right?
Yeah,
so that's really
exactly.
powerful. Okay,
Exactly.
interesting.
We definitely don't want people to end up with a giant bill if they wrote a bad query.
Yeah.
We probably will add throttling capabilities, but as I said, it has to be something that you give us a way of knowing whether you want to be throttled or not. It cannot be that we throttle people on high load by default, because what if they just hit the front page of Hacker News? They're going to need all the compute they can get.
Yeah, absolutely. Yeah, that's a valid point. Cool. Whenever I talk about storage and compute separation, there's always some talks about, okay, what about performance? What about latency? Because now you are fetching data from some other service, right? So what kind of optimizations are done there to make the queries, let's say, equivalent to how it would work on a Postgres database, like the vanilla Postgres database?
Honestly, I think we're getting a lot of benefit from being specifically for those OLTP workloads, because they typically fit quite well in memory. So we make sure when we move things around, we obviously make sure to warm up so you'll have data in memory. But other than that, what we've noticed is that once the data is loaded, there is you don't it's very rare that you need to hit disk on large scans, and this is something that developers who are used to building OLTP applications, they're also very good about planning for that. They know that if they have to hit disk a lot, if they have to do a lot of reads from disk, it's actually, even on local disks, honestly, people make a big deal out of compute storage separation, but local disks have been a fiction for a very long time. You use EBS now, and EBS has some nice optimizations and NVMe and all those things. But before that, your data was probably on a large NetApp cluster or Symmetrix or one of those EMC things. Like, databases were really never on a local disk. And so in many ways, the thing about the compute storage separations that we're bringing, the fact that you're no longer using local disks, because if you have a database, very likely you never used local disks. What we do is the fact that the database is aware of where the disks are located and aware of certain aspects of the separation, and can use this information essentially. But yeah, I think the coupling was always a bit of a fiction. It's just I'm trying to figure out the right way to say it, but basically in the past it was still in two separate places. Like EBS is a storage cluster that you will be using. It is just that it was hard for database to take advantage of the fact that the computer is separated. You couldn't do failover by just attaching to your compute to an existing EBS disk. I think today you can, but this was prevented for a long time. And in NetApp and so on, I think it was never something that people just did for a bunch of reasons. So you always had a separation. You always paid the cost of sending bits over some LAN to somewhere else. You always read over some LAN from somewhere else. You could never take advantage of that. So I think this is the big revolution around compute storage separation. It's not the fact that they're separate. It's the fact that you can now use the separation to your advantage.
Very interesting. Yeah. And that does make sense. That probably has a lot more concern for, I don't know, like real-time analytics or some really high-performing use cases where they might have to do some optimizations, let's say cache some data or do something like that. But I think for most of the use cases, it should just work fine.
Just to be clear, we are caching, right? Postgres caches. It has
true.
a buffer cache. I think the main difference between us and an analytical use case like maybe ParaDB is that our use case means that 99.999% of the time your data will fit into memory. While analytics typically talk about a lot more data, it doesn't fit into memory. So yeah, they need all the tricks they can get in order to make sure that running a report or searching for something over terabytes of data can actually happen fast. You know how much memory machines have these days? Some Nile databases, they are on bare metal machines in AWS. The smallest one is 0.5 terabyte of memory. People don't get how much memory is actually available out there.
That's quite a lot. For small, medium companies, I think that's their entire
It's
database.
way more than enough. Yeah.
Very interesting. Cool. Another problem that I've faced, I don't know, multiple times is database migrations, and a number of outages have been happening every once in a while because some migration did not go well. Once you have this kind of separation where, based on tenants, how do you make sure that these migrations are seamless and not actually creating problems for the customers?
Yeah, that's so. Just to be clear, we're talking about like schema migrations, right? In
Yes.
columns. Yeah, that's a fantastic question. We really invested a lot in that. Some migrations are relatively straightforward. So let's say you're adding a column with no default value to some table. It's the only thing you need to really worry about in that case. A, we have to distribute it for your tenants. That's
Yeah.
one of them. And B, if the table is high traffic, taking a lock is actually dangerous. You don't, because as you probably know, but to remind the listeners, most DDL actions in Postgres need an access exclusive lock, meaning that while the DDL is happening, which can be in a transaction with multiple steps, nothing else is allowed to run and to access those tables. And this, if you have a busy system, it's almost equivalent to a downtime. So this can be a disaster. Some of the operations is fast. So you'd think that, okay, it happens in nanoseconds. Nobody is going to notice, which is usually true. Two edge cases for that. A, if you wait very long to acquire the lock, you're actually preventing new transactions from starting. So you can create a downtime while actually not doing the DDL, just waiting to be allowed to do the DDL. This is absolutely catastrophe. The way that, and there's best practices in Postgres how to prevent that. So if you read the usual recommendations, you listen to a talk, they tell you first thing you do, try to acquire all the locks with very short timeout.
Yes.
And then if you succeeded, fantastic, run the DDL. If you failed, it's a short timeout, nobody noticed. Basically, this is what Nile does for you. You don't have to remember to set the short timeout and take on the logs. We proactively take all the logs for you and with a very short timeout. If this failed, we'll basically tell you we failed, we've been unable to acquire the logs. It happens surprisingly often, like even I was running some tests locally, and I didn't notice that I have some load running in the background, and I was trying to do a DDL, and I'm like, yeah, it keeps failing to acquire the lock. So we have that. The other thing that can go wrong very often is that you do begin transaction, alter table, and then the developer goes to get some coffee and forgets to commit. And now everyone is locked until the developer is back. So again, our short lock timeout takes care of that. It will basically get canceled and rolled back. The developer will come back from getting coffee and will say, oh, fuck, it rolled back. But at least it will not hurt anyone else. Now, some DDLs are actually a lot more challenging. They both take longer and can fail because of customer data. So imagine that you're doing alter table, add unique constraint. It can work on most of your customers, but one of your customers actually have duplicate data, and you cannot do that. So first of all, it can take a long time because if it's a large table, it is a full scan. We do it in parallel on your different tenants, so it can be faster. And then what happens if really one tenant has a duplicate? So right now, in order to maintain consistency, we roll back everything. If we discover, and hopefully we discover quickly that one tenant cannot take this constraint, we will roll it back. We do not allow you to have one tenant with a different schema. This is a thing we're hoping to change and give you the option to basically say, migrate some of my customers. It can be accidentally, as you said, 2 customers could not migrate, but more common is to say, actually, I'm still in beta testing. So I only want to migrate customers who signed up for my beta program, not everyone. So we're playing with some ideas around that. But right now, we are basically all or nothing system. You have to make sure that you can migrate all your tenants or the DDL will completely roll back, because the worst thing is to be unintentionally in this in-between state where different customers have very different schemas.
That is so powerful. If I'm able to do like this phased schema migrations, for some use cases, that would be actually very powerful.
I know, right?
Yeah, absolutely. One thing I noticed, you mentioned that, so if I'm doing a schema migration, you do this in parallel for different tenants, right? And then if one of them fails, you roll back. How does that work? Because that is a transaction across tenants then.
Yes. So this is why we have a transaction coordinator, and it works with a two-phase commit. So essentially,
Okay.
when you do, first of all, you never do a DDL when you are inside the tenant. You cannot have the tenant context set. So you connect as a developer with your developer credentials, and then you do alter table. We capture the alter table for you before. This is why I'm happy that Postgres has so many nice hooks in the that extensions can hook into. So before the Postgres handles the alter tenant, it calls us. We move it to the transaction coordinator, and the transaction coordinator basically takes all the logs from everywhere, and and once the logs are taken and succeeded, it distributes the alter table. It waits for everyone to come back and say, I distributed it, but it doesn't commit yet. It waits for everyone to come back first. Once everyone came back, it sends prepare transaction for commit, assuming the developer did commit explicitly or implicitly, prepare transaction for commit. Everyone says, yes, I'm ready for commit. At this point, Postgres already writes it to the commit log. So even if something fails when the machine recovers, it will already be there. And then we send commit prepared, which basically finalizes the process. Everyone committed, we get success, we tell the developer everything is successful, and the process is completed. So the usual two-phase commit shenanigans. And it's really nice how Postgres implemented two-phase commits for us, like the prepare for commit versus the commit prepared. It basically has a table with everything that is prepared. So when we recover, we can really say, okay, this one agreed that it's prepared, but did not finish the commit yet. This one finished because it's no longer in that table. Everything is okay. This one didn't even, it's not even in the prepared. It didn't even agree. It was a no vote. So we know what to do in this case. It's basically we use this mechanism for kind of a distributed consensus. Everyone has to vote that, yes, we agree that this DDL is going to happen, and then we do two-phase commit to finalize it.
Wow. So that does mean that you already have system in place to also provide the customers to run transaction across tenant IDs.
Yes, we do.
Ooh, okay.
We don't know how scalable it is. Right now, we have a single transaction coordinator. Obviously, scaling transaction coordination is really hard.
Yeah.
And OLTP systems are known for very high rates of inserts and updates. Like this is defining characteristic.
Right.
So we are not, but we don't know what percentage of it will be cross-tenant. So we're basically taking it slow and not opening more capabilities until we know exactly that we can really deliver the features that people want and not something that is not good enough for them, I would say.
Yeah. That definitely does seem like a very rare use case where probably some companies have it. Very interesting. And I would love to read more on that. If there is a blog, please send it across. And
there is no blog, unfortunately, not at this level of depth. I gave a talk about it in two conferences. One is System Distributed and one is PG DevConf. And they're both online on YouTube, so we can hunt them down and share it.
Yeah, I'll make sure I add it to the YouTube description as well so people can take a look. Awesome. I want to also touch base on the AI use cases because it's like AI is everywhere, right? And now with vector embedding storage in Postgres, it's really becoming more and more powerful. So first of all, let's try to understand what does AI native mean, and what are the AI use cases that NileDB can support really well?
Yeah. First of all, AI native is a marketing term, not a technical term.
Yeah.
And the idea is that a lot of companies that start now, let's say that today you wake up and say, I want to do a new travel agent for companies, like trip actions, but new. I'm going to do a better trip action. You will do it with AI. 99% chance you will do something AI related, like the AI chatbot to find the best flights for you, AI chatbot that recommends what you should see when you go to some city, hotel recommendations, whatever it is, there's going to be a chatbot involved. And there's two things. First of all, customers do expect a smarter experience these days and the ability to get more personalized interaction with a bot that will say, I want a hotel that specializes in romantic evenings and has a nice restaurant, and it will go through all those recommendations and find something for me. And the other part is that you're going to raise money, and investors expect AI to be in the description as well. So this is what AI native actually means. The fact that if you start a company today, it will have AI somewhere in the pitch deck, and probably the product roadmap, AI will be involved. Now, the type of products that are really good on Nile are when you want to do retrieval augmented generation. So instead of just asking a generic chatbot like ChatGPT-4 a question, you want to provide him some context, so you'll get more relevant answers and less hallucinations. It will actually have some information, immediate information to answer you with. And so you need to get this information. And in Nile case, it's especially good if the information that you want to retrieve is specific to a company. For example, hotel recommendations, this is shared public data. Anyone can access it. It can be in Nile, but it's shared table. It's not tenant specific. But if you are doing an HR chatbot and you want to ask it to pull some relevant CVs or check something in the company policy, this is very specific for each tenant. Super important to have isolation. The last thing you really need is a bot to give you some answers around based on some other company's policy, or accidentally share your amazing recruiting pipeline with some other recruiter. This will be a bit of a disaster. So this is a fantastic Nile use case. And one thing, we started with that. You have some data, you need to use it with your AI to make it more grounded, but you need to make sure that it's per customer data. But then what we discovered is that vector similarity search takes a lot of memory and a lot of CPU. And it's just because when you have millions of vectors, it's a very large index. Those are very specialized indexes that are not really normal things. They are things like it's probabilistic indexes. So unlike the B trees that everyone is used to, what they do is, for example, there is an index called IVFF flat. It actually separates the data into a bunch of lists. And then based on your search term, it first decides which lists are more likely to be relevant. And then it tries to find the relevant documents on those specific lists. HSNW, which is HNSW, which is the other popular one, it has those layers. So at first it tries to find something relevant in this layer and scans that layer. And then it goes one layer deep based on that and scans another layer, and goes few layers deep to try to find the relevant documents. So there is different ways to look at that, but the key thing is that those are really large indexes. So obviously, if you want to search all of Wikipedia or all those hotel recommendations, you have no choice. You have to search all of them. But what if your million embeddings are actually 1,000 customers with 1,000 embeddings each? Embeddings are very small and very fast to scan. You probably don't even need the index. And those indexes, because they're probabilistic, there's also probabilities that they will not find the best documents. It's approximated nearest neighbor. But if you now have actually a fairly small list, you can afford to scan all of it. It's not going to be all that slow. Yep. So now you have 100% probability of finding the correct document. So, and then if you have a lot of tenants, you can also say, okay, some tenants should have an index. They are large. Some of them maybe not very large yet. I'm not going to create any, or maybe create different indexes. So this is another thing about those indexes, is that you configure them for your data size. If you remember the example with you have multiple lists, if you have fewer embeddings, you need fewer lists. If you have tons of embeddings, you need a lot more lists. You need to tell it in advance how many lists you want. So you probably need a specifically optimized index for every tenant. This is another really good reason to have this kind of isolated data for every tenant.
Very interesting. So it's like mixing
the best of both worlds, where you have tenant separation, and then you have the vector embeddings, and then that not inherently becomes like smaller embeddings because you have less data per tenant. And
Yes.
okay, that is also very powerful. Good. Nice. Awesome. I have hundreds of more questions. We can go really deep into this, but I want to ask you, like, in this journey of building Nile, what are your like top learnings, if you have to share, like technical, non-technical? I'm usually more interested into technical learnings like Postgres and I don't know, storage, compute separation, whatever, but also non-technical learnings. What are these?
Yeah, so first of all, for me, actually, one of the biggest technical discoveries was that Kubernetes is actually quite good these days. I started this journey being very anti-Kubernetes, and we started without. And we migrated to Kubernetes when we started having more usage, more customers. We wanted to scale better. And I think because my first experience with Kubernetes was when it was like 7 years ago or something. It was very young. There was all those issues. Everything broke. I had to read the code to even understand what's going on. So I developed a very negative mindset around it. And now that we moved to running on Kubernetes, oh my God, a lot of things are so much better. We have better CI/CD. Deployments are way faster than they used to be. So yeah, that was a very nice quality of life improvement and definitely changed my mind on that. The other big learning for me was really around security and especially authentication and isolation, authorization. Like their security is a giant field, as you probably know. And I thought I know some stuff. I knew a tiny percentage. There are so many different protocols, layers upon layers of protections. So I've been luckily, in all cases, I've been learning from my team. I've been learning by hiring really good people who know what they're doing. But this was definitely, it's something that we learned from customers that they're very sensitive to security. And anything from isolating by using not containers but micro VMs because this has better compute isolation, isolating by and storage layer, like all the layers of isolation, the different ways they want to authenticate and the pros and cons of each, being able to sometimes say the customer asked for something but we don't think it's secure enough, so we're actually not going to do it, sorry. This has been a really interesting learning experience. On the non-technical side, I would say that the biggest learning has really been around how to prioritize, because I think as technical people, we love those architectures and we love separating computer storage and all those things are building transaction engines. All those things are really exciting to us. But at the end of the day, if I cannot translate it to meaningful customer value, and hey, it's not enough that I have compute storage separation. Here's how you benefit from my compute storage separation. I cannot, like, it doesn't matter what I do technically. I need to be able, I should only do the interesting technical things that bring real benefits to the customer. Otherwise, I'm wasting my time on the fun tech of the day, which is fun, but startups require a lot of focus.
Awesome. I just remembered, I guess if maybe I'm remembering something mixed, like it was a blog or it was your Twitter or something, but there was a quote from you that I absolutely loved. And I don't want to misquote you, but it was something like, we make money when our customers win or our
Yes.
customers make money. So could you say what it was exactly?
Yeah, it was a reference to our usage-based billing. If you think about it, we charge for compute. When are you
Yeah.
going to have compute? When you run queries. Now you're not going to run queries for fun, hopefully.
Yeah.
It will like because we're a platform for building applications, and we expect most of the traffic to be driven by your application usage. Your tenants are using your product, and in return, you're running more queries on their virtual tenant databases. So for us, we are making money if your tenants are very active. Now, how to turn your active tenants into your money? This is your problem, right? I cannot solve that for you. But for me, if you're paying us, it means that you have very active customers. We have very generous free tier. You can run, I think it's something like 50 million CPU milliseconds or something. It translates to about 20 hours of database usage every month for free. So you need to have customers run enough queries to use more than about 20 minutes of database time in order to start paying us. From all my testing databases, unless I'm doing a load test, I can never generate enough traffic as a developer writing an application that costs even a cent. So we expect that we will get paid if you have a lot of users, essentially.
But that is such a beautiful product mindset. I absolutely loved it. I guess you shared it on Twitter or something, but probably I don't remember exactly. Awesome. Thanks for sharing the learnings, and also thanks for sharing all the insights about NileDB. I'm sure we have only covered like a drop in an ocean of different concepts and features, but I'm really excited to try out the features, and also I'm excited about what's in the future. So talking about the future, what exactly are you planning to release like in coming months, if you can share that?
Oh man, we usually don't pre-announce things, but we're working on two separate tracks. First of all is partnerships. So we announced our partnership with Netlify, and we want to announce a lot more using Nile with other vendors and having really strong built-in integrations. I think will make life much better for developers. The other place is that we have features that work really well and we just haven't launched. So we are going to basically relaunch, I would say, our authentication layer. It already exists, but we are really pushing hard now on enhancing it and adding a lot more capabilities, a lot more integrations there. So we are excited about the relaunching tenant-aware multi-tenant authentication, because like it's just so difficult for so many developers, and one of the things where Nile really makes it a no-brainer.
Awesome. Well, thanks a lot for joining and sharing the insights with me. It took us some time to do this, but I'm really happy that we did this. So thanks again, and I really look forward to releasing this episode. And please share all the links, the NileDB and the blogs, and probably some references that helped you build NileDB. I'll just put everything in the YouTube description so our viewers can learn more from your learnings. So thanks again, and see you soon in some other episode.
Thank you. It's been a pleasure.